Hey everybody, today I'm about ready to go out and take some data on the Camaro, and what I'm looking for is spark knock data. Now the challenge here is that on my 85, the way that the ECM is set up, I can't get spark knock data. There are kind of two things. One is that in order to get data out of this ECM for the scan tool or for my laptop, you have to use what a 10K resistor across the line, which is built into the wire. It's available, but that puts it into what's called field service mode, and field service mode bumps up the idle speed on this engine anyway. It bumps up the idle speed to about 1,000 to 1,100, and it advances the timing. And it has a number of other things that, the book says, don't go trying to take dynamic data with field service mode active. So I need a workaround. And if you watched my previous video when I was troubleshooting the ESC spark control knock code 43, when I did code 43, I made up some jumper cables so I could put the jumpers between the connector and the knock module and read the voltages. So what I'm going to do today, let me show you here. It's pretty well done already, but down below in the back there is the knock module, and you can see that I've got individual wires coming up from the knock module that come up to the connector that was on the knock module. And they're Metropack. I went and ordered pins and made up little jumper cables. And then on top of that, it's hard to see, but I put some electrical tape around them to make sure they couldn't short. It was hard to come up with a connector body to make a jumper other than individual pins. This one uses 4 wires, and pin A is not connected to anything. At least on my car. Might be in some other ones, but in this one, pin A is not used. The red wire, I put a breakout in, and it's connected to it's a voltmeter cable. And I happen to have an old Radio Shack meter that has, I don't have it plugged in yet, but there's a RS-232 data connection on the end, and my laptop has logging software on it. So my goal, what I'm going to do is, I'm going to go out and run, and I've tried my best to insulate everything, isolate it so that it won't short out and damage something. I've got to really be careful, because if the pins get together, I could smoke the module or, cause other problems. So right now, essentially what happens is the knock sensor feeds into that module that's in the back there. This is like fuel pump relay, and the knock module's on the back. And then the knock module feeds a voltage to the ECM, and I'm picking off of that voltage to read it. I'm going to record it on my laptop as a time history, and I just want to see, the car should be at stock timing. I'll probably double check it later, but it should be at 6 degrees stock timing, and I just want to go out and drive it and see how many times I get into knock and how much margin I'll say I have in the timing. What I really want to do is come back and bump the timing up higher and see if I can detect a change. But I'm going to get myself going here, and we're going to go out and take a drive. So here's my setup, and I've got the ignition on, so it's reading about 9 1/4, which is standard voltage for no knock. Cable goes down. It's an RS-232 to USB. And this is the meter view software that's on my computer. And so when you get a knock, the voltage should drop. So I'm just going to turn this on. I'll start logging it. It's set up to log every 1 second. And there we go. So there's 9.24 volts. And I'm going to light it up and get out on the road, and we'll see what I get. Alright, so it took me a little while here. I got the engine warmed up, and so far it's thoroughly boring. I'd like it if the engine would warm a little more, but it's on the thermostat now, and in the summertime, I mean, that's like 195. You know, the fan doesn't kick in till, what, 210 or 220. But so far, I don't have any wavering, I'll call it, in the voltage. It's a 9.30 and it's rock solid steady. Probably didn't even need a logger, but hey, you just never know. So, and it's a little noisy because I've got the window cracked so I could bring the wire through without pinching it. Made several good hard accelerations, and I've made several part throttle accelerations. And so far, other than when I accidentally bumped the meter and knocked it off scale, no indication of a problem. Now, it's a 35, 40 degree day. It's not hot like midsummer. But my curiosity was, you know, how close did they calibrate this engine to the edge of needing a knock sensor, right? And so right now, with this factory cal in here, you know, I don't see any signs or any indications that I don't see any wiggle in the meter that indicates that I'm getting any knock, which is hey, that's a good thing. So I'm going to take her back to the barn and back to the garage, and I'm going to double check the timing, probably bump it up a little bit, and come out and take another run at it, see how that looks. So here's my chart that I got from this last run of data. It'll turn out that the timing was at about 8 degrees. I was a couple degrees up from stock, but you can see that across time, the voltage is pretty doggone stable. There's a couple spots where there's some ripples. And there's 1 or 2 spots toward the far right where I had a pretty good drop, where it looks like I did do some wide open throttles that may have gone ahead and bumped into the knock sensor. There were a couple anomalies where where I bumped the gauge of the meter, and it gave me bad data, and I cleaned those. It was a few seconds where the meter actually stopped responding. But anyway, it was all fixed, and it's pretty quiet. The knock sensor does a few things, and I'll just caution that, I'm running a meter with a 1 second rate, so it's possible for things to not show up on the chart that happen, a really quick response. However, I was watching the meter live, which is a lot faster than the recording version, and I'll just say you can tell the voltage didn't vary very much. All right, I got the EST disconnected, and I checked the timing. It's actually sitting at about 6 to 8, and I'm going to bump it up a little and see how that works. In there about 8. All right. right, I've got it sitting up about 12 now, so see how that works. Well, I'm back out here running, and with the timing at 12 or 13, and last time I was at 9.3 volts on the sensor, always. I mean, I never wavered unless I did something, interrupted the recorder. But now I'm just a mile or so out, and well, first of all, it's running at 9.26, which doesn't sound significant, but I'll just say it was kind of erratic coming out of the driveway and even at idle coming away. And it's dropping, it's just hundredths of a volt, but it's like, even right now, it's at 9.24, suggesting that it's on the edge of something. And I'm going to go accelerate away here, but as I was accelerating, you could see it drop and hash and come back up. I can show you that, but that's about where we were at, I guess. It's holding at about 9.25 or 9.26. I'm cruising along now at it's 55, and very interesting. If I step into it, not much happened on that one. But let's see here. I want to make a stop and let's accelerate away and see what we get. 9.24, 9.25. It's just doing kind of a normal accel. It's holding fairly steady. But I would say, where we're at, the difference between 8 and 12, that 4 or 5 degrees is significant. What I was going to try to do here is see if I can get it it's in high gear and lug it a little bit. Question always is, how fast is this system? And will I actually see it, or does the computer respond so fast that if you get significant knock, it responds faster than my meter can read it, which is also possible. Okay, so here's my chart for 12 or 13 degrees of initial advance, and you can see, first of all, just look at the line going all the way across compared to the last one. There's a lot more hash in it. There's a lot more. It seems like it's right on the edge, and then you've got 3 places where you had a pretty big spark retard, and the deepest one that goes down there to about 8.5. And again, my meter doesn't, it's a digital meter, so it doesn't, the display doesn't update every thousandth of a second. And this screen doesn't update that fast. It's got a 1 second is the fastest I can get it to go. But I'll say, so 2 things. One is the factory cal, or the factory timing, is more stable and doesn't bump up against the knock sensor very often with 87 octane gas. And this one does some amount, but I did run the throttle hard, and I did run it through a bunch of things, and it's still not bad. Now,
if I was tuning, I've bumped up the spark curve all the way across, and it may turn out that I maybe just want to bump up the spark at maximum at wide open throttle. But what I ran into, and the reason I'm not running this all the time, is that the part throttle and the idle and so forth, it seemed like it was too much spark for the way it wanted to run. Um, if I had my druthers, I'd probably concentrate on putting some spark at heavy throttle and not anywhere else.
All right, well, I've got it all back together and the timing is set back to 8. It's just 6 is spec. I usually run it just a couple degrees over. But that's interesting. So if I get up to 12 or 13 initial, that moves the curve enough that I start bumping into the spark knock sensor. And it feels stronger. It feels like it's got more power, but you're running right on the ragged edge. So it's probably not a good idea to run that high. But as I say, that was information. Now that's information running on 87 octane standard pump gas. Probably if I went to 89, that might knock that away. I mean, the engines are calibrated to run on unleaded regular. In our altitude, that's 87 pump octane is normal. So, well, in any case, that's all for now.